Okay, so I'm going to show a little ADU that we did a few years ago, and I've sort of retroactively applied Energos to it. So this was actually built twice on the same site, and it's kind of a convenient project to demonstrate Energos for, 1 hour, hour and a half meeting for a couple of reasons. One is that there are a lot of different conditions. It's got a conventional roof, it's got a rooftop deck, it's got a conditioned space over a carport. So it has lots of different conditions in a very small footprint, about 1,100 square feet. It's got doors, it's got windows, swing doors, sliding doors, and so forth. And then the other thing that makes it helpful is that it is small, and so it's not necessary to go to, to show you 500 different windows. I can just show you 6 and you'll get the idea. So just a little bit of background. As I said, it's about an 1,100 square foot accessory dwelling unit. It's got a compact living room, open plan kitchen on the ground floor. That poses certain questions for Energos, and you'll see why later. It's got this straight run stair here on the north edge, little toilet room tucked in under the stair, washer dryer stack in a closet under that, HVAC closet over here, little pantry, and then a U-shaped kitchen. Some storage outside, which we're not going to worry about today because that's not conditioned space. And then upstairs, the stair comes up, lands, there's this little office that overlooks the stair, so that's another kind of a condition. And then a primary bedroom with a walk-in closet, and then a secondary bedroom with a tiny little bathroom tucked away back here, and then this rooftop deck. So like I said, small project, but there's a lot that's crammed in. So and then this isn't really directly relevant, but I did want to show you this view because HVAC was actually kind of challenging on this project, and so I ended up modeling the floor trusses, and then working out with the HVAC contractor ahead of time where all the duct runs. So supply is green. I'm sorry, return is green, supply is blue. And one of the nice things about, well, the good news, bad news is in this kind of contemporary sort of box, there is no attic, as is often the case. So it's a little tricky to do HVAC for those of us who are used to doing that in attics. The good news is that it forces you to run most of your mechanical ducting in the interstitial floor. And what that means is that the vast majority of it is within the thermal envelope. So that's a benefit for energy performance. Anyway, so while I've got this slide up, let me say a little bit about what Energos is and what Energos isn't. So it's a module that comes standard with Vectorworks Architect or Vectorworks Designer. Designer has sort of all of the different industry tools. It has landscape, it has Spotlight, it has Architect, it has some machine design tools and so forth. So Energos is built in. It's not this add-on or third party that you need to add. You've got it now, whether you use it or not, in all likelihood, unless you're using Vectorworks fundamentals. And what Energos is an energy analysis tool or module. And I use those words very carefully. It's not an energy modeler in the sense that I would use that term. So energy modeling, for those of you who've worked with that, requires finite element analysis of spaces, and it requires very detailed information about all of your wall assemblies, your whole envelope assemblies, what your mechanical systems are, times of day, average weather data, occupancy loads, and so forth. And that kind of energy modeling is very useful for confirming compliance with various model energy codes. But I don't really think of energy analysis, and probably there are those who would beg to differ, but I don't really think of energy analysis as a design tool in the sense that it's going to give you early information in schematic design or early design development that is going to influence your design very much. On the other hand, Energos is an energy analysis tool, not an energy modeling tool. So there's some trade-offs. It's going to give you some general calculations about your building performance, but it isn't a finite element analysis tool. In other words, it's not breaking up your model into small cells a few inches across and then calculating energy flow from one cell to another, to another, to another in all three dimensions over time, like an FEA software would. Rather, it is built on top of the passive house kind of rule set for calculating or estimating building energy performance. And so you can think of that as more like a really, really complicated or really well-developed Excel spreadsheet rather than calculus, basically. So, so the trade-off is it's less detailed and possibly less accurate, but so those are the downsides. The upside is it makes energy analysis, again, not energy modeling, far more tractable early on in design. You don't need to know the specifics of your mechanical system to use Energos. You don't even need to know the details of your wall assembly. And I've got some detailed wall assemblies here in this model, but you'll see in some cases, I've decided to override the calculated R value of those envelope assemblies for good reason, and I'll explain why I've done that in certain cases. You don't even need to know what the exact U factor or R value or solar heat gain coefficient of your windows. You can start by making some design assumptions about all of those variables and get some information back from Energos, which could potentially influence your design. So in other words, it's a great tool for exploring some what if scenarios in your design, in schematic design or design development, as opposed to being a predictor of your actual energy usage in your building, or something that's part of a certification protocol where you're going to get a certificate that a building official is going to say, yep, you've met these prescriptive energy requirements. So in a nutshell, it's a design tool, it's not a certification tool. So I'm just going to stop right there just in case there are any questions, if you want to unmute yourself and chime in. Okay, interrupt me later if you like. So I'm going to go ahead and jump in. So just think about these trusses as we go on. So there's a few things that you really need for Energos to work. You have to have walls, floors, and roofs. You need to have an envelope of your building. And so that just goes without saying. Ideally, you'd have doors and windows in those walls. But those are the things that Energos is going to be looking for in your model file: walls, floors or slabs, roof objects, doors, windows. You don't necessarily have to have every single wall calculated, contributing to the Energos calculation. So if you zoom in here, you can see that I've got some exterior walls where there's an insulation graphic that's applied to that. And then I've got some interior walls that just have a gray shading, right? This is pretty much just ignoring, it's not pretty much, it is ignoring all these interior walls, and it's ignoring all the interior doors. All I really care about in terms of the envelope are exterior walls and doors. And if I click on a wall and I look at it in the object info palette, you'll see at the very bottom of the OIP, it says wall here, right? And if at the bottom it says Energos, there's a little Energos tab. And you can see that I've checked include in calculations, and I've given it a boundary type. It's an exterior wall. And you can also see that Vectorworks has calculated the R value of that wall. And I'll talk about that in a minute. All right, so you need walls, you need slabs, you need roofs, you need doors and windows. That's one major set of components that you need in order to use Energos. So if you're just sort of using Vectorworks like SketchUp, and you're just taking some rectangles and you're extruding them and you're clipping them and tapering faces and whatnot to make kind of a massing model, Energos is not really going to be able to do anything with that. You're going to need walls. The other key thing that you need is you need spaces. So that's what I've got here in the green. And you see they're numbered 1 through 7. And then I've got some spaces on the upper floor as well that I've color coded just for fun, a different color just to make it easy. And spaces are really pretty easy to create. I'm just going to go over here to my, space planning palette, right, which looks like this. And you can see there's a space object. And I have a couple of different ways that I can draw a space object. I can either pick some boundaries. So I could pick a series of walls and have Vectorworks generate a space from those walls. I could use the paint bucket mode or the inner boundary mode. So what that would look like is something like this. I'm just going to delete this space for a second, and I'm just going to take this paint bucket mode, and I'll just click inside of here. And you can see that Vectorworks has created a new space. It's renumbered at 27 because I've been fooling around with this file, and somewhere along the line I had space 26, so it went to the next one. I can rename that. That's no big deal. All right, so you can see that it filled right into the inside of the wall. And if that wall has components, it's going to go to the very inside face of the component. Now, in my case, I'm building my walls with a baseboard component, which is not necessarily advisable. But that's why that space is offset 3/4 of an inch from the chipboard, because it thinks the baseboard is a full-on component, even though it's only 2.5 inches or 3.5 inches tall or whatever. All right, so that's how that's going. The other thing I could do is I could just draw the space like with a rectangle tool, right? So I could just zoom in here and then drag to over here and get a rectangle going, right? Or I could use a polygon tool and start drawing some spaces, right? Now, if I'm drawing the spaces manually, and you can see I was really sloppy with that. If I'm drawing the spaces manually, notice that I can just draw them out, pardon the pun, in space, right? I don't have to bound them to anything. So it's not a bad idea to have your spaces be bound to your objects or to your walls. And you can see in the space object that I've just highlighted here, the one that I deleted a few minutes ago. Let's see, where is it? Well, I'm not seeing it off the top of my head, but let's just try this. We'll just move this wall 2 feet and see what happens. Yeah, so those spaces didn't go along. And if they had been bounded to the wall, then they would have been, I think. Let me double check. So pick those walls. There we go. And now I'll move the wall and see if that moves the space with me.
A quick question, Francois. Do you
Yeah.
use Space Tool for schematic design work?
You can, or you can use rectangles. No, it didn't follow the wall. Yeah, you absolutely can. You could. I tend to use rectangles, but you could just draw some rectangles, and then from the AEC menu, you could create objects from space, and you could take a rectangle and convert it to a space object. I'm sorry, create objects from shapes. Right. All right. So you need some spaces, and you can see that spaces can have. They can be 2D only. In this case, I've got this show 3D clicked over here, and I can display my volume by either gross or net. For my purposes today, it doesn't really matter very much, but so if I wanted gross volumes, that I might have spaces that meet at the center lines of demising walls, for example. All right, so I can choose gross or net, and then I can also bind that space to my stories. So in this case, the bottom of the space is set to the layer elevation, and the top of the space is set to the default layer wall height. And so in 3D, that looks something like this. There's that same upper floor. That space, I deselected the 3D, so now it's back to 3D. You can see that. And so, yeah, we've got spaces. I put them in my non-plot class. You can kind of see here in this window over here how the space is kind of coming right up to the middle of the window, kind of like water filling the room, right? And so it used to be in earlier iterations of spaces, they were always prismatic rectangles or something like that. So in other words, the tops of spaces were always flat. But more recently, spaces can accommodate vaulted or sloped ceilings. So in this case, I just highlighted a floor. I'm just going to move it out of the way here. So I've got a flat ceiling over these two rooms, but in the bedroom here, I've got a vaulted ceiling, and in the bathroom here, I've got a vaulted ceiling. I've got a vaulted ceiling in a couple of these spaces. So if I really want to be quite accurate with my, if I want to be accurate with my spaces and show correct volumes, I can go ahead and select those spaces. These are the vaulted one, these 5 space objects. And you can look in the AEC menu and hunt for it, or I can just go to the help menu and in the search field start typing fit. And we're probably many of us are familiar with fit walls to objects. Well, under the space planning menu, there's a fit top of space to objects. So I can go ahead and fit those spaces. And instead of a fixed height only, I can constrain the objects to everything on, say, the roof layer. You can see I've got my roof here grayed out, to the bottom face of the, say, bottom component, for example. And yep, I think that should do it. Let's try that. And you can see that these space objects have reshaped themselves. I'll undo and then redo. So you can see how those space objects have reshaped themselves in order to fit to the geometry of that roof. Now, on the lower floor, I've got this stair that I've turned off, right? So I haven't bothered to sculpt this space for the lower floor. But I could, if I needed to, go ahead and do that. And speaking of the lower floor, I've got this open plan kitchen, right? And so I've just assumed that there's going to be different heat loads in the kitchen than there would be in the living space. Even though it's all one space, I could model that as a single space, or just for the purposes of our looking at it today, I modeled those as two different spaces. So you can see that I can create a bounded space here with just sort of an imaginary wall between them, if you will. So I've got my spaces, and if I want Vectorworks to calculate the volume of my building in order to make Energos more accurate, instead of typing in some assumed values, I can go ahead and, again, under the space planning, where did it go? Here it is. Under space planning, I can fit the bottoms and tops of space objects to other geometry in order to have a more accurate expression of that volume. So that's second on the list. I need envelope components, walls, slabs, roofs, floors, doors, windows. I need spaces. And then the last thing that I need is, where is it? I need a heliodon. And so, the heliodon is going to do two important things for me. It's going to set the location of the project, and it's going to set the orientation to a certain degree. But most importantly, it's giving me the location. And so Energos is pulling in assumptions about weather data based on that heliodon. So the default heliodon, when you just drop one in, is Washington, D.C., because that's the major city that's close to Vectorworks. So if you just drop a heliodon in and it's Washington, D.C., and you're doing a project in Montana, you're going to get messed up results on your Energos analysis. So be sure and set your heliodon to the correct location. So having done all that, let's sort of look at a couple of other things here. So here's a view where I've set up some doors and windows and isolated everything else. Now these doors down here in the little storage locker or storage closet, those aren't doors to a conditioned space. And so you can see if I scroll down to the bottom of my object info palette with those two doors selected, I have include in calculations deselected because I'm not heating or cooling that space. So what those door characteristics are makes no difference to the energy performance of my building. Now, if I look at a window, for example, and let me look at the settings of the window, you'll see that there is an Energos tab, and there is an area for shading. I'll get to that in a second. At the top, you can decide whether that window gets included in calculations. Again, if it's a window for an enclosed space that's conditioned, you want to include it. If it's a window that's for your greenhouse out there somewhere, don't include it in your calculations. And I can go ahead and type in a manual input for the R value of the window. I can get that from the manufacturer. And of course, that's the R value of the entire unit, right? So generally speaking, even from the same manufacturer, a casement is going to have a different R value than a double hung, than a fixed window, than a slider, simply because of the ratio of glass to sash. And so really, if I want to be absolutely accurate, I'll just plug in the manual input from the manufacturer's cut sheet, or I may not know, right? It could be early design. And so I may not know, and I could just plug in something like an R value of 3, for example. If I want to automatically calculate that window, there are some presets that Vectorworks gives me, in this case, Plastic Modern for the sash. And then I can do double glazed. And then there's a list here. And so I can add additional glazing characteristics. But really, for most purposes, it's I find it preferable and easier simply to make a manual input for my windows based on either the manufacturer's cut sheet or at least a plausible scenario for that window. Now, one thing that Energos doesn't do, again, because it's not a finite element analysis energy modeler, it's an energy analysis tool. It makes some general assumptions about shading for my windows and my doors. And so you'll see that there are some shading characteristics: general, surrounding, summer, and then additional shading. So what that basically means is, for the general shading, if it's a south-facing window, or I guess potentially there's someone from the Southern Hemisphere here. So if it's an equator-facing window, then the general shading is going to be none or low. And if it's a north or polar-facing window, then the shading is going to be, the general shading is going to be high, right? So that's what that setting does. So for the sake of simplicity and just this kind of meeting today, what I've done is I've created 3 different window styles. They're geometrically, all these windows are the same. They're based on a vinyl or a fiberglass window in terms of its general thermal performance. But I've created a style for south windows, I've created a style for north windows, and I've created a style for east and west windows. And the reason I've done that, let me go to my settings here. And I'm not sure if I can choose a style. Yep, nope, I don't think so. So let's see if I can do this with a custom selection. Select only. I'll create a Python script, why not? And we'll say field value. Wonder if symbol name will do it. That might not work. No, that's not working. Don't think there's a field here for style. skip that. But what I've done is all my south-facing windows, of which I happen to 3, you see that those are in the south style, right? All my east and west-facing windows. Oh, yeah, those are all windows. Those are all east-west, and then my north and north. And really the only difference in those is under Energos for the east-west windows, I've made the general shading medium, and you can see that that is grayed out because that's just set by style. And then the surrounding, the summer shading, additional shading, all of those are variables that I can change on a window by window basis. So surrounding would just be what the general environmental shading is due to adjacent trees, other buildings, right? So that could be none, low, medium, high, none. And then for my summer shading, what that basically means is whether or not I have an overhang at that window, whether it's or a small overhang or no overhang, or some part of the building that is going to shade it as if it were an overhang. And that, again, could be none, low, medium, or high. So those are kind of the parameters. And then additional shading would be interior or exterior blinds or shutters or whatnot. Now, the bad news is, I guess, that if I were to model, say, a bunch of awnings or canopies over my south windows and my south door in order to evaluate how that would affect building performance, it doesn't matter. I can model those shading devices and recalculate, have Energos recalculate the performance of the building, and nothing would change, right? Because again, this isn't really a finite element analysis. It's not running, you'll see when we do the calculations, they're very quick. It's not running a year's worth of solar animations to evaluate how much of specific window is being shaded or exposed to direct solar insolation. Rather, it's relying on you as the designer to sort of tag that window as either, what degree of shading that window has. So the bad news is adding a bunch of awnings doesn't affect your Energos calculations. And when I say adding a bunch of awnings, I mean like actually modeling them. The good news is you don't need to model all of your awnings. You could simply take all of your south windows and then change the summer shading from none to high, and that would give you some idea of what the impact would be of adding those awnings. And in fact, we can do that. So there's just certain inherent characteristics of the tool based on how it's designed to be used that it's important to understand what modeling will or won't do. Like, these image prop trees aren't doing anything for my Energos calculations. I just have them there because that's where the trees really were on site. And so it's a helpful visual cue for me to evaluate, oh, is that a highly shaded window or a slightly shaded window and so forth. So same thing for doors, whether they're glass doors or whether they're solid doors, they also have an Energos tab. So if I look at the settings, right, that has an Energos tab. Exact same thing. I can set the R value. Here I just set the R value by style. And then I can give it general, surrounding, summer, and additional shading. And I only had 2 sliding doors on this project, so I didn't bother creating a separate door style for different orientations. I just manually set them. Any questions about that? Okay, I'll move on. So let's talk about our walls, or just our envelope in general. So Here's a wall. You can see that it's a styled wall. And if I scroll down to the bottom, you can see that Energos has included that in its calculations, and that it's calculating the R value as 10.6 R value. So let's look at those settings. And I'm just going to go to the style rather than the instance of the wall. So you can see that my wall has all of these components. It's got stucco, sheathing, wood stud framing that's insulated, gypsum board, and a baseboard, right? So let's look at those components in turn. So the stucco, I've got a class for that. And you can see that there's this value called lambda. And for those of us, which includes me, who are used to thinking of thermal conductance and thermal resistance in terms of either U factors or R values, lambda's a bit of a different animal. It's the thermal conductivity of the material, but it's using the proprietary passive house sort of methodology. So it isn't a number that you're going to readily recognize and say, oh yeah, that looks right in terms of the U value of my material. Luckily, there's this little lookup table. And so I can either have Vectorworks calculate lambda from a given U value or an R value. That makes it pretty easy. Or I can just select from a predefined list. So I can just type stucco. If I spell it right, it'll find it. And so stucco has a lambda of 0.4334, right? And so that's how it's getting that number. I'm providing a thickness, and so it's taking that into account, right? Likewise, my sheathing, I've assigned that as the lambda of OSB. There it is. And similarly for my wood stud framing, right? Now here's where wood stud framing gets a little interesting. So I'm going to give us a little detour in just a second. So basically, I've assigned a lambda to all of these components except the baseboard, because again, the baseboard is like 2.5, 3.5 inches tall. It is not having any meaningful contribution to my wall thermal performance. And so I've just set the lambda to 0. So it's okay to have components that you just ignore. If you have cavity walls and you have an airspace, you can include the airspace between your masonry finish, or if you have a rain screen, whatever, you can assign lambdas to all of those things. Now, wood stud framing is a little tricky. And the reason for that is that, of course, there isn't insulation everywhere and there isn't wood everywhere. There's a mix of wood or metal and insulation. So on this little sheet here, I've got a little hot link. So I'll open the link. Yes, I knew that. And I might need to share my screen. And someone's just sent me a chat. Don wants to know why the R value on my insulated studs is so low. It's actually quite high, Don. You might have been looking at the lambda value. So there's lots of R value calculators. I just found this one. It's by this outfit called Ecotrope. And so it gives you a wall calculator, a floor calculator, and a roof calculator. And so what I could do is build my whole wall assembly and then plug that back into the Vectorworks model. Or I'll just go ahead and close all of these layers and just look at this interior wall, right? And that's going to be cellulose spray foam to a depth of 3.5 inches, wood studs at 3.5 inches, a width of 1.5 inches, and let's say it's 16 inches on center. And I've got an R value of 3.7 per inch. And with the stud spacing that I'm stipulating, it gives me a overall R value of 10.018, or a U factor of 0.1 for that portion of my wall. So again, because I'm not modeling every stud, and because I'm not filling the voids between the studs or the cavities with, Vectorworks solids that are classed as cellulose spray insulation, spray foam insulation, this is a perfectly acceptable sort of methodology. So that's giving me an R10 roughly. And so if I go back to my Vectorworks window and go back to my wall, let's look at that, edit the style. And so on this layer here, instead of looking something up, I can just calculate from a given total transmittance coefficient. And I'm going to need to divide that by 3.5 or an R value. So I'll just say 10 divided by 3.5. And the material thickness is 3.5 divided by 12. That's the fraction of feet. All right, and I'll hit OK. And so that corresponds to a lambda of 0.1, which is very close to a U factor. And so when I hit OK and OK, I'll go ahead and replace the Energos data as I update this wall. I haven't changed anything else about it. And that is a really low R value. You're right, Don. So I think I need to give the total 3.5 inches, or the total R value of 10. So let's go back and edit the style.
Is it deducting the windows, Francois?
No, it's not deducting the windows. It's just, it's not multiplying the R value per inch by the 3.5 inches of that component. It's just giving me an, let's do this. Let's try that. Yeah, so now you see it's giving me an R value. So now it's got a 12.12 for the whole wall. Right, and this wall is essentially the same. It's got a 10.5, so I'm going to go ahead and fix this wall. This model started in an older version of Vectorworks where I couldn't set my component heights on a wall-by-wall basis. I had to do it by style, so I have a different wall style for the upper and ground floor. So I should update that to a single wall style, but that's okay. I can go ahead and edit that. Okay, hit okay. Okay. And that should give me 12.12. There we go. So that's good. And then, of course, the parapet wall, I don't care. That's just a parapet wall and it doesn't contribute. So notice it is not included in my calculations. Similarly, for this roof assembly, if I edit that style, you can see that I have an R value for all of the different components that I haven't bothered to fill up. And again, because I have sort of a similar situation here where I've got roof joists, and then I've got foam, or roof rafters, and I've got foam. And so working out all of that on a component by component basis is going to be misleading, because if I just count the framing cavity as the foam insulation and miss the rafters, then I'm going to overestimate the insulation value of that component, right? So here again, it's useful to use a tool like this Ecotope, and it's got a roof calculator. And so I use that to override the R values of that roof assembly. And I think I chose close to 18.5, which it's a bit low, but I was probably being a little conservative on the thickness of the foam. And the other thing that I want to say about overriding these R values, why that's really useful, is that when you're very early on in your design and you don't know what this wall is, you haven't decided whether you're going to make it a 2x4 or 2x6 wall, whether you're going to use bats or foam insulation or blown-in blanket, or some other perhaps more exotic or novel system. I don't know, hempcrete or something like that. You may not have a specific wall assembly that you need to model. Well, you could just model your wall as a generic 6-inch wall or 4-inch wall or 8-inch wall, or whatever in your design judgment seems appropriate, and then you could just assign an R value to it. And then you could start using Energos to say, okay, well, what happens if I change my walls from R12 to R16 or R20 or R15? Does that really make a huge difference to my overall building performance? And I think that's where the tool is really the most interesting, is that when it allows you to look at some different scenarios. All right, so we can take it for granted that I've assigned R values and U factors to all my windows and doors, walls, my slabs, this roof deck, right? So that's a slab, and you'll notice that it's being counted as a roof. And then this is a roof, and it's being considered as an exterior roof, right? And then down here, I've got a slab for the foundation under that ground floor, and that is called out as a floor, and it's an exterior slab facing down, right? And here I've got this floor here, and that's an exterior slab facing down. And I should probably have modeled this floor with a little bit more granularity, because you can see that part of that is spanning over the carport, part of that floor is spanning over unconditioned space, and part of that floor is spanning over conditioned space. So I should really model this as 3 separate slabs, one of which is an exterior slab facing down, one that's a slab with an unheated enclosed space below, which would be the little storage closet, and one with that's just an exterior slab facing down. So those are my options. And so sometimes, depending on the conditions above or below my slabs, I may want to break it up into different components. So this is actually a ground contact slab.
Francois?
Yeah.
What does it mean when you say slab facing down?
Well, so this is a slab that has conditioned space above it and unconditioned space below it. So the exterior environment is below it, right? This is also a slab object, but it's being treated as a roof. So in terms of the type of object that Vectorworks uses to model these two floor assemblies, one is essentially a roof and one is a floor. But it's the exact same Vectorworks object. They're both slabs. And so I differentiate those as being an exterior roof. In this case, it's a roof, and the other one is a slab with unconditioned space below it. That makes sense?
Well, didn't your slab on your first floor slab also say it was a slab facing down?
Yeah, and that was a mistake on my part, and I just corrected it to be a ground contact slab.
Gotcha. Thanks.
Yeah, I wish I could say that was a deliberate error that I made in order to demonstrate the different options that you have for your slabs. So I've gone through and I've modeled everything. And again, I'm showing you a project that's quite, I mean, it's basically complete, right? I pulled this model out of a file that was for construction documents. And so I just want to stress that you can use this tool much earlier, right? When you could just make your openings just all fixed windows, and you could just throw a U factor at them, and you could make your walls just generic walls, and your roof could just be a single component, and you could just assign an R value to it. It doesn't, you don't have to have your gutters and downspouts and drainage and light fixtures all modeled in order for you to use Energos at all. In fact, it's probably better if you use it as early as possible rather than, late in the game. So when I've done all that, assigned R values to my envelope and to all my components, make sure there's a heliodon and there's some spaces in there. And by the way, I went a little overboard on all these spaces, just for the sake of demonstrating this. If I, is there really going to be a significantly different thermal performance for this bedroom versus this office versus that bedroom? No, I could probably model all of that just as a single space object, maybe even for the whole upstairs, right? Because it's not like Vectorworks is giving me a space by space report like, oh, this space is going to overheat and this space is going to be too cold. It's really using the spaces in order to calculate the total volume of the building. So at its simplest, I could have just modeled this as two spaces, a ground floor and an upper floor. And for early design, that would probably be just fine. Yep.
Hey, on your second floor, how would you divide the spaces to assign different insulation characteristics? Like carport would have insulation, but the second floor over the other conditioned space wouldn't have any insulation, probably, right?
That would be assigned to the slab itself, not to the spaces. The spaces are just volumes of air.
Okay, so you would create different slabs for those areas?
Correct.
Okay.
Correct.
Got it.
Which I didn't bother to do here, but I should.
Okay. Got it. Thank you.
Yeah. All right. So under AEC, there's this Energos. And let's look at our project settings. So there's a setup tab, and you've got a basic and advanced. And I recommend that you start with basic and that you work your way up to advanced after your design has matured. But I'm going to assume that it's early in design, and we want to see kind of where are we at roughly with this project. Yeah, so Don's asking me if I've changed the heat load in the kitchen and the living room. No, I haven't. I just modeled them as separate spaces. So here's the setup. It's deriving the project location from the heliodon. I can get more advanced with that. I can fill in some project information. And then next, I'm going to look at usage. And again, under the basic setup, I have this sort of menu of different kinds of uses that my building might be. In this case, it's a single family residence, 2-story, no PV panel. For the building itself, I'm going to tell Vectorworks where to gather all of the thermal envelope information. So Vectorworks isn't really checking to make sure that my geometry is solid, right? In other words, I could have 2 walls that don't meet, and I could have a gaping hole in my building. And Vectorworks doesn't care about that. It's just looking at the surface area of the wall times its R value or U factor to determine how much energy is being transferred from one side of that wall to the other. So in the case of my, let's just call a spade, poorly modeled slab here, right? Where I've used the exact same slab object that spans over unconditioned space, over enclosed unconditioned space, and over conditioned space. Vectorworks has just taken the total R value of that slab. So I'm probably getting optimistic results here. In fact, I'm certain that I am, because Vectorworks is assuming that this whole slab is insulated, and so that's problematic. Which is to say, there's real opportunities for user error. So I'm going to tell Vectorworks specifically which layers I want to collect all of this envelope information from. And I could choose all layers, but if it's early design, maybe you're sketching and you've got some different variations of the design that you're working on, or you've got some walls that are kind of, little scraps of walls or pieces of roof or slab that are just kind of floating around. You want to be disciplined and not have any extraneous stuff, because if you do, Vectorworks is going to tally that up. So I'm telling it to pull the envelope information from my floor 1 and 2 layers and my roof layer, right? And I can specify specific classes, or I can say all classes. And if I say all classes, basically any of those objects that in the object info palette, there's a checkbox that says, use Energos calculations, include in calculations over here, right? It's gonna hoover those up. So it's seeing 2 roofs, it's seeing 12 walls, it's seeing 18 windows and doors, and 2 floor slabs, basements. And I can click on this list and I can sort of go through all of these, and I could either show just my roofs, right? I can turn these off, and I can select on the drawing. So it'll isolate it for me so I can inspect it and make sure that that is in fact something that I want to include in my calculations. Or I can just look at my doors and windows. You see, here's a bunch of doors. These are all interior doors. And Vectorworks is ignoring them because I'm telling it not to choose my interior doors as part of the calculations and so forth. So this building element list is kind of an opportunity for you to make sure that everything is being tallied correctly. And then I can either plug in relevant floor area and my total volume, or I can just use automatic calculations, and it's getting those values from the spaces. So here's my spaces list, and it gives them a random numeric string because I don't have a unique name for them. And again, I can pick one and I can select it on drawing, and it'll turn it on, or it'll select it for me and take me to it. Just like selecting a door or window from a door schedule. So once I've got the building all set up, then I can choose some basic systems. Again, this is the basic configuration. So in this case, I'm going to go with a heat pump, a fresh air exchange, and a tankless hot water heater. And then I can look at my results, right? And so I can look at overall energy performance, and then it'll break that up into building envelope, building surfaces, and then give me a carbon footprint. Now I've got no on-site energy generation. So if I wanted to add a PV array, then I could, under my systems, I could include that. And I can go ahead and update my calculations. And you can see that when I changed those walls from an R10 to an R12, it got marginally better from whatever I calculated before. And this is BTUs per square foot per year. And I can look at my building elements. And this is, you know, architecturally speaking, this is kind of where it gets sort of interesting. Because you can see that my overall building envelope is this line here. It's in the green, so you know that's kind of reassuring. But you can see that this is not, this 26,000 BTUs per square foot per year is not an average of my roofs, walls, windows and doors and floors. It's the sum of all of these. So what are the biggest contributors? My floor slabs and basements, that's the biggest contributor. My roof is a relatively small contributor. My windows and doors and my walls are, you know, about contributing roughly equally. So if I want to get to some low-hanging fruit here, this is sort of useful because it's telling me that I should really be paying attention to my floor slab if I want to improve thermal performance. Maybe I need to model a floor slab that has perimeter insulation, for example. Or it might tell me that my walls are contributing a lot to my total load. And so now it's giving me, based on my locations, it's giving me some general information about what my heating energy demand is, what my cooling energy demand is. Hey, it's Austin. What a surprise. My cooling energy demand is almost twice my heating. What my heat and cooling load is per square foot, and so forth. So anytime I make a change, right, if I want to select all of my walls, for example, right, so I could select all my exterior walls on the ground floor, and I could go to, well, let's go to these upper walls, and instead of using the calculated R value of 12, I'll just override that, and let's try 15. Likewise, do the same thing for the downstairs walls, override that, and choose 15. And then I want to make sure that these walls here are not included in my calculations. And I want to make sure these doors are not included in the Energos calculations, which they're not. Now, the other thing that I can do is I can drop an Energos label, looks like this, and that's under the Energos. There's a create label command. And that's nice because it gives you a nice little grade. So there's a report card you can show your parents. They'll be very proud of you. But the nice thing about the label object is that you can double click on it. Well, I guess not. You can click on the Energos button and it'll, so that's kind of a shortcut, which is why I like to use it. So we just changed our walls from 12 to 15. And so I can update that. And hey, look, we definitely got a bit of a bump. If I look at my building, you can see that my walls, and even to a certain degree, my windows and doors for some reason, are now contributing a lot less. About 10 or 15% less than they were before, which, that stands to reason because we bumped up our R value by 10 or 15%. So, so that's where I think the tool is really great, because it's not going to give you this, detailed analysis of your mechanical systems. And for most of us, we probably know just enough information to be really dangerous about that. But it is going to give you some interesting scenarios. So, I can see, well, what happens if I do change the shading coefficient? Let's say I want to put a south-facing awning, right? So this door, I'm just going to go to those settings and the Energos settings, and the summer shading, instead of medium because there's a tree nearby, I'm going to make that high. And for additional settings, I'll maybe I want to design some kind of a rolling exterior shutter or something, right? And maybe I'll also have that awning, whatever it ends up looking like when I design it, extend over this south-facing window as well. So summer shading from none, I'll make it high. And I won't, it's my little slot window, so it's architecturally precious to me, so I'm not going to shade it with a shutter or some blinds. And then I can go back to Energos and say, well, did that really make any meaningful difference? So I'm at 42,400 BTUs per square foot per year, and so that awning alone saves me about 3,000 BTUs per square foot per year. That's not, that's not inconsequential. So I've just dropped my cooling load. Now, when I go back and fix that slab that's insulating over the living room, I'm probably going to take a hit on my performance, right? So that's kind of what I like about the tool. And of course, we can go ahead and probably a little low on time, but if we go to back to setup instead of basic, we could go to advanced, right? And then we can start to get really detailed with our usage. It's residential, it's a dwelling. We can have a set point number of mechanical units. We can make all of these sort of appliance selections as far as what they are, gas, electric, condensation, dryer, and so forth. For building envelope, we can add thermal conductivity to ground. We can add thermal bridging. And for our systems, we can have a ventilation, heating, right? We can get a lot more detailed in our cooling, heating, hot water systems. And then under electricity, this is where I would choose on-site electricity generation. So I could do a PV array and what the equivalent BTUs per year that would be, do a little bit of calculation there. And then I could, once I plugged in all those numbers, then I could get some more detailed information. Okay, surely there's got to be some questions or things to review. Anyone have anything to ask? Michael wants to know if Energos results can be exported or translated into ResCheck. Man, I wish. No, unfortunately not. Not to my knowledge anyway. You can see that I have some either passive house standard or Minergy or LEED or BREEAM or ENEV standards. So that just basically tells me what scale, right? So if I wanted a passive house standard for this, I might be looking good, you know, just as against sort of business as usual general construction. But by passive house standards, I really need to work a lot harder here. And you can see that, you know, some of that is air tightness result, right? That's just a number that that's getting plugged in as an assumption. Vectorworks isn't modeling air tightness, obviously, but sadly, there is not a direct export from Energos to ComCheck or ResCheck, and you know, I've certainly have made that request, and you should too. Other questions? I've not compared these results to ResCheck to see how they stack up. ResCheck is a pretty low bar to meet. But I guess, Don, what you're asking is, have I looked at the ResCheck calculations and the Energos calculations to see if the values are similar in terms of like R value times area? Is that what you mean? Don? Yeah, that's what he means. Okay. I can't imagine. I mean, I suppose you could, you know, you could go ahead and plug in all your Energos values, and then you could just manually translate them from Energos. Or I guess you could also, yeah, so you could take your, I'm trying to remember if there's an export feature where I could export all of these and at least manually plug them into ComCheck or ResCheck. We do not have a continuous installation requirement in Austin yet. Though, of course, that's certainly recommended. And so I would, you know, definitely model wall styles where we were using that kind of system with like an R3 or an R6 continuous exterior insulation. And that's certainly not only going to improve the total R value of the wall, but it's going to make a huge difference to thermal bridging in terms of real world performance. But yeah, to my knowledge, that tends to be more emphasized in colder climate zones. And it's, I'm sure it's encouraged and it's certainly coming, but it's not codified here yet.